Okay, we're going to take a look at the geometric mean. Now, what the geometric mean is going to be and how we're going to use it to begin with here is it's an altitude drawn from the hypotenuse of a right triangle, okay, to the right angle. So hypotenuse up to the right angle. This goes and breaks the triangle up into two smaller, similar triangles to the original one. So I'm going to give you a moment here, and I want you to make sure that you have this written down. All right, so let's continue on and see how this goes. So I want to prove that this is going to be the case. Now, when we're dealing with similar triangles, and especially if we're dealing with a complex situation like this, draw them out. So the first one I've got here, larger triangle. And that turns out to be A, B, C with the right angle down here. Next triangle I've got, triangle B, D with the right angle there, and C. And last but not least will be this triangle over here. And that will be A, B, and C with the right angle being here. Now, first question. Are all right angles the same? No. I thought all right angles are 90 degrees. Okay. Well, okay, they're not on the same thing, but anything that's identified as a right angle is 90 degrees, correct? So they all have the same measure. Now, is this angle measure up here of A the same as the angle measure over here for A? Would that make sense? Okay. So if I know two angles in a triangle, do I know how big the third one is? Well, after all, they'd add up to 180 degrees, right? So if I take off 90 degrees for the right triangle, then I subtract off the value for A, wouldn't the value down here for C be the same as this angle over here? It would have to be. Well, that means if this is B, then this is B over here, and that's the same, right? So, and that means that this C over here would have to be the same as the A. So, when we're dealing with similarity, angle is one of the things that we can use to identify whether or not triangles are similar. Okay. Also, it helps identify which sides are congruent to which sides. So when I write this down, I want to make sure that I identify each angle or each vertice with the correct one. So if I start over here with A, then I go B, and I go C. So over here, A corresponds to C, so this would have to be angle C. Then it's going to be angle B, D. So ABC goes to CBD. Why? Because A goes to C, B goes to B, C goes to D. When I get to the last one then down here, A, C, and B. So we did this before when we were looking at congruent triangles. We still need to make sure that the vertices are listed in the proper order. Okay. So with that idea in mind, I want you to go through and give this practice problem a try. When you figure out what each one of the triangles names are, you can put it into your Chromebook. Because now you should see that it says enter the triangles. So you just put the letters in. There's no way for you to put anything in for the little triangle symbols. So just put in your triangles, which ones go to which, like A, B, C, D, E, F, E, F, G. Give you a few minutes to work on. Okay, so there are the answers that you guys put off. Some of you, okay, So I'm looking at this one right here. We got DEF, DGE, DEF, DGE, FEG, GEF. Close. Okay. It looks like most of you've got it in the proper order. So let's take a look at this. So the first triangle that I've got here, okay, triangle 1. I've got D, I've got E, right angle, and I've got F down here. Now I have another triangle here, and that is going to be E, G with the right angle there, and F down here. There's one more triangle sitting up over here, and that is going to be listed as D, E, G with the right angle sitting here. Now obviously angle D here and angle D here would have to be the same, yes? Okay, so F down here would have to be the same as the F down here. Okay, so those are congruent. But because we know that if we know two angles in a triangle, we definitely know the third. These two are the same, so that goes with that. These two add up, and so we know that this goes here that way. So the order could be D, E, F, and then from this one, D would have to correspond to E, so this would be E, wrong color. That'll be E, then we'll put in G, and then this will be F. Then over here, we're starting off with D again, then this is going to be G, and last but not least, we should end up having E. So that is listed out in the proper order. So make sure that you go through and do that, especially when these complicated shapes like this. So as we go on, we're going to be getting more information for it. And again, it's just good practice to go and draw these things out so that you've got a quick sketch so you know what is what. So I've got this one here, so this one is going to be P, Q, right angle, and R. Then I've got one here that is going to be P, Q, S with the right angle there. Last but not least, I've got this one down here, which is going to be Q, R, and S, with the right angle being there. Now I want to fill in as much information that as I possibly know. So I'm looking at this, I got a 3, I've got a 4, I've got a 5. That also means that this one down here is 4. Now I'm looking for PS and PQ. Okay. So I'm looking for PS up here. We'll call that one X, and then I'll call PQ over here. This is going to be my Y. So what I want to do, if I have one triangle that has all of the information into it, then I can go through and set things up and continue on from there, right? So I want to set my ratio. I want to know which ones correspond to which. So it would probably be a good idea to identify the corners that go with each other. So it looks as though P up here would go with P up over here, correct? R down here would go with R down here. So now I know what the rest of them are. Corresponds to Q. This corresponds to R. So if I want to, I could also go and mark the sides. So hypotenuse, 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 and we'll go to the longer side, and longer side, okay? And then I'm just going to leave the other side blank, because all I really want to do is just set this up so I can see what's going on. So if I want to go and solve this one, this ratio will end up being X over 4 is supposed to be equal to. So down here, which corresponds to X? Well, X corresponds to this side, so that's going to be 4. Okay, then I need the 4. 4 is on the blank side. What's the blank side over here? 3. So that means that it's going to be 4 times 3 divided, or 4 times 4 divided by 3, which turns out to be, in this case, 16 over 3, or if you like, 3 1/3. So that is going to be the value for X. Okay. Does that make sense? Yes, no, maybe so for those of you not paying attention. Okay. What? Oh, really? You mean 3 goes into 16 5 times? Yep. Last I checked, you were correct. I'm glad somebody's watching. So I got 5 1/3. Now is it right? Now I need to set the same thing up over on the red one. So Q to R. Q to R has a distance of 5 here. So that means I get to use 5, and I'm looking for Y. So again, which one corresponds to which? So we set this up. That's going to be Y over 5 is going to be equal to, corresponds over here. Well, that will be 4 over, and then the shorter side is 3, which is what we've got there. So for this one, 5 times 4 divided by 3 gives me 20 over 3, which are reduced down to 6 2/3. So that would be the value for Y. Now, when you're going through and doing these things, having the labels set up makes life a lot simpler. So what I'm going to do is I'm going to give you a few moments here, and I want you to go and work this one out and see what you can figure out for the sides. You'll have about 3 minutes. Once you got your answer in, make sure that you put it in. All right, so we got the answers there. First one was supposed to be X, not Y, X. So we got X is equal to 18. Well, let's see if we can verify. So we got one triangle here, large one. That turns out to be, we've got no points up here, do we? We just know that this is the right angle here. This side here is 18. This side here is 30. This side here is Y. For this triangle, we have the following information, that this here is 18. This is X, and the right angle is down here. For the last triangle, we are told that this here is the right angle, this is Y, this is going to be X, and this is going to be 30. So, question is, do we have a ratio to go and set up to begin with? What? Oh, that's not 30. I wrote that down there. That was my bad. So, that's the pieces of information that we end up having on this. Sorry about that. Now, which sides correspond to which? So hypotenuse, we got the hypotenuse, and we've got the hypotenuse. Okay. So these two sides correspond to each other, but they're equal, but they're not the same size, are they? So it's probably a good idea that when I'm drawing this out, I also identify which vertices go with which. It does help a little bit. So if you need to, you can put in the A, you can put in the B, you can put in the C, and you can put in a D. So this is going to be A, B, C, A, B, D, A, D, C. So do we know which ones are equal to which yet? Well, we know that B corresponds to B, so that means C corresponds to the other one, corresponds over here, so that corresponds there. Okay, so finishing this off, a to 1, mark that there, and that there. So now I know exactly which ones are congruent to each one, right? Or I should say congruent or similar. So as I look at this, the only thing that I have to start with is this one over here. Okay, 18 over 30. Now when I'm looking at this, I need the small one over here, 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 and here. I don't have enough information to that. By the way, could I go and figure out why now? What kind of a triangle is this? Right triangle. So could I use the Pythagorean theorem to go through and figure out what the y is going to be? Okay, so turn that on, clear this out. That means I would have 30 squared, right? It's a squared plus b squared is equal to c squared. So if I take 30 squared, subtract off 18 squared, I get that value. Then take the square root of that, and I end up with 24. So now I know that y is 24. Y is 24. We've got that piece of information. Now can I easily go through and find x? The answer is yes. Got all the information over here. X is going to be identified in either one of these. It won't really matter. So if I go and take the hypotenuse inside 2, so over here that would be 30 over 18. This is going to be equal to, over here, as 24 over x. That makes sense? But again, you got to go through and write it all out so that you can see what it's got to be. So we're still looking to see what x is supposed to be. So that would be 18 times 24 divided by 30, and we end up with 14.4. So the answer for x is supposed to be 14.4. Let's scroll down. Anybody come up with that one? Nope, I don't see a 14.4, but I do see that somebody put y in there as that. And if I click the next one over, come on, let's go. I get 24 over there, so a few people had pulled that one out. Okay. Again, it is imperative to go and draw this stuff out. So, next thing that I've got for you. The geometric mean can also be calculated out in another way. If we have this ratio, a over x is equal to x over b, this is one of the ways that we can deal with the geometric mean. So really what we do is we multiply the two numbers we have together and take the square root of them. Now, excuse me, now there is also another formula that extends this out. This is the formula for the geometric mean. Okay? You take the nth root of how many numbers are multiplied together. So if I got two numbers multiplied together, we take the square root of them. If I have three numbers multiplied together, I take the third root of them. If I have four numbers multiplied together, I take the fourth root of them. It's not that bad. It's just how the formula works. Now, how we're going to use this. Okay? I want to find the geometric mean of 3 and 12. While I could set this up as the ratio, it's a lot quicker and easier knowing that the two numbers I have are multiplied together, take the square root of them. So that means it's going to be the square root of 3 times 12, which is the square root of 36. Well, what's the square root of 36? 6. Quick and easy. Geometric mean of 2 and 18. Square root of 2 times 9, which gives me the square root of 18. Now, if they want you to go and round it to the nearest tenth, well, you just simply take a calculator and take square root 18, and I end up at 4.2. if they tell you to write it in radical form. 18, does 18 have a factor that's a perfect square? 9. So that means it's square root of 2 times 9, or actually I should rewrite it this way. The square root of 9 times 2, what's the square root of 9? 3, square root 2. And there you go. So, what I want you to do here is to the nearest tenth, I want you to find the geometric mean between 4 and 11. Give you a minute or so here to do that. All right, here we go. So, let's see, we got 10.2, we got 6.6, 4, 11, 1, and 4. Okay. So, well, the geometric mean for this one is simply just going to be the square root of 4 times 11. So it's the square root of 44. So on the calculator, we would just use second square root 44, enter, round it to one place, so that would be 6.6. That's all it is. So, okay, give you a few moments here, and I want you to give this one a try. All right, looks like everybody's in. So here, do that. Okay, 4 square root 2, 4. Okay. Okay. So when we work through this one, we find that we have the square root of 2 times 16, which is the square root of 32. Now, in simplified radical form, does 32 have a factor that's a perfect square? And the nice thing is they actually gave it to you right there as it was working out, 2 and 16. So that means that I'd be looking at the square root of 16 times 2, square root of 16, square root of 2. Square root of 16 is 4, so it'd be 4 square root 2. So how it should have been in here would have been 4 SQR 2. That is how you would see it on a calculator depending upon what type of software that's on the calculator. So just to be aware of that. All right. Now, there are 2 more corollaries that go with this. So I'm going to give you a few moments and I want you to get those taken care of. Now, these are going to be some rather handy little rules for you to deal with. So make sure that you've got them down. And if you need to draw out a picture with these so that you know what it's going to be, do that as well. That'll be rather helpful for you. So that ends that. Lessons due at the end of class tomorrow.